Hello and welcome back to part 3. We left off with identifying weakest links, and of course in the info security class in the spring we learned the weakest link is of course the human element, but here in this chapter we're just talking about hardware. So in this case a defective firewall ACL and access control list might be a weak link if it's not kept up to date, or if it's not closely monitored or updated or changed, depending on the situation. And number 5, preventing any, here we go. Number 5, identify and protect single points of takeover. And I guess this was just a slide leading up to firewall control server that's kind of linking all of these together as a single point of takeover. So here's the example that if an attacker takes over this one box, they've got access to everything else. So for security, this is called a single point of takeover, but this leads to my principle of good network design, number 2. So if you're talking about network management, I would say no single point of failure. For security, it's no single point of takeover. For network management, it's no single point of failure. So a single device, if this goes belly up, none of these devices can connect to your network anymore. Similarly, here, even if it's not hacked, if this box fails, it's still a single point of failure, which gets back into issues of what are the business requirements for uptime? Does this box need more redundancy, or do you need 2 boxes that are working in tandem and some kind of failover capacity or load balancing capacity? And then number 6, least permissions and access control. Giving people the least amount of access they need to do their job and no more. Least permissions gets into the difference between authentication and authorization. So remember, authentication is just determining you are who you say you are. That's different from authorization, which says once you determine you are who you say you are, here's what you have access to: this server, that printer, that folder. And each authenticated user should have the minimum necessary. So for example, it's really a poor practice to give users administrative access to their local computer. Most companies don't do that anymore. But all of these principles we're treading very lightly on, because we get into it much more seriously in CMIS468-Ch4-Part3-Fall2015. The last bit on security has to do with policy management. There are 2 aspects, creating the policy and then implementing the policy. So for example, you might have a high-level policy saying we use strong encryption for any transaction that involves credit card numbers. The implementation would have to get much more specific, so you'd have to document what type of encryption, where the encryption takes place, and how. Gets into the technical specifications. So the policy is not going to be technical. The implementation is going to be very technical. But then there's a third aspect of oversight. In order to have effective policy management, there needs to be some kind of oversight. You have to audit your policies, make sure that people are doing things the right way, make sure your servers are doing things the right way, making sure your firewalls are doing things the right way by checking log files. Maybe it's by doing some penetration testing, but I have this formula here, which is worth remembering. Good implementation plus good oversight equals good protection. It's oversimplifying, but it's a good principle. Just please keep in mind that every information system is made up of 3 things. I say this in every class, but the 3 things are people, process, and technology. So in terms of security management, you have to manage all 3 in order to have good security. And with that, we're switching gears once again back to network management. We know what ping does from the homework assignment. You may not, some of you that are already in the workplace know how frequently you use ping. Ping is your go-to tool for a network administrator for determining if something is online and determining if there's any latency on the network. If you need something more than ping to give you more detailed information, a very common protocol to use is SNMP, Simple Network Management Protocol, SNMP. This is a standard that pretty much every network device, every smart network device, is going to support this protocol. And the way this works is there's a server that's gathering information from all the devices. However, the server does not talk directly to the box. You can't talk directly to the hardware. It can only talk directly to an agent that's running, so a piece of software or firmware that's running on the box. So a test question there that the manager talks to the agent, not to the box. When something happens, an event happens, and an error takes place, an alarm, maybe it's temperature, maybe it's number of bad packets, number of errors, amount of congestion, some alarm goes off, that sends a trap. I call a trap an alarm. A trap is a programming term, therefore I don't use the term trap, but sends an alarm. And the alarm populates something called the MIB, the Management Information Base. This is just the central database that SNMP is managing. So whatever network management tool you're running is probably running off one network management box. And typically this is just a very simple server. It doesn't even need any redundancy. It can be a very simple server. On a small network it can be a PC, but typically it's going to be a small, just single processor server that's gathering all this information. There's lots of good network management software out there, HP OpenView, IBM's Tivoli. There's some big names out there, but before you go spending tens of thousands of dollars on network management software, I would encourage you to check out what's available for free on the internet. There are lots of free tools, because all of these tools just use SNMP. They're using ping on the back end. They're using some RMON probes, remote monitoring probes, or something extra that you pay for with some of this network management software. But the best tool I ever used was something called Servers Alive that would simply automatically send out a ping to all my servers and network gear once a minute. And if something it failed to respond to a ping, it would immediately send it a second ping, and if it didn't respond to that one, it would send me a text message to my phone. And that was very helpful in anticipating, because you don't want the CIO to be the one calling you to tell you the network's down and go, oh really? You want to be able to say, hey, I'm on it. I already know it, and I'm already fixing it. That's the way to be a hero in the networking world. The last topic in this chapter is a tricky one, which has to do with software-defined networking. Now, SDN, software-defined networking, is a very new cutting-edge topic in networking, and I will not pretend to be an expert at this because I have zero hands-on experience with this technology. I understand at a very conceptual level what it is, and more importantly, I understand why it's important. So I'm going to focus on the why here. That you're in my day, a device made forwarding decisions and control decisions in the same box, and so your switch was making control and forwarding decisions, your router's making control and forwarding decisions, access point, firewall, every device is making control and forwarding decisions. SDN is kind of breaking these out into the switch just does forwarding, which is obviously much faster. The router just does forwarding based on a set of rules, and the access point just does forwarding the messages based on a set of rules. But the control function is centralized onto an SDN controller, so it's abstracting a layer here and ripping it from each device and putting it on a separate box for greater management. This has everything to do with network management. The reasons for this are part of it is cost reduction, but more importantly is the agility in terms of being able to make a change to the control function on the fly. So here you can make one change here and it pushes out that change to all your devices on the network instead of having to manage each individual device. So rolling out a change is much faster. That part I certainly appreciate. So now we come to Tim's principle number 3 of good network design, which is always design with management in mind. You might call this the principle of laziness, and if you want to, that's fine too. But you want this to be you, not old wearing a tie. I don't know why he's wearing a tie at home in front of the fire. But you want this to be you in your PJs, with your dog in your lap, sitting by the fire with your laptop, able to completely manage your network remotely from anywhere. Now, part of this, if we get sidetracked on server discussion, you really need to buy some lights out boards for your servers. Maybe I'll get into this in class. It's kind of out of scope for this class, but lights out boards are fantastic ways of kind of using backdoors into your servers. For your network devices, the problem with managing a network device remotely, say you have a router that goes down in Japan, how do you remote in? How do you SSH? How do you telnet? How do you remote into that box to reboot it if you can't get to it physically? Part of the answer is out-of-band management. So out-of-band management, this is not in the book, but it's important, refers to accessing a box outside of normal bandwidth channels. So instead of going in through the WAN port, you might have a console port that's connected to an old-fashioned modem, just a regular dial-up modem. Because you don't need a lot of bandwidth just to manage, send text, command line interface back and forth. You don't need any bandwidth for that. But if the router's offline for whatever reason, you can always dial into the router through your back door and reboot it that way, or look at the log files or see why the interface is down. So having that redundancy, that out-of-band method of remote management really gives you the warm fuzzy. And that's saved me a lot of times. So the key to all this management, you'll notice, I want you to make this connection. It's not so much technical knowledge, because you can always find somebody smart and grill them to get the answers on how your network is laid out, but documenting all this stuff. So in order to manage the network, you have to design a good network. In order to design it, you have to be able to document it. Documenting a network means knowing exactly what the business requirements are, not just, oh, it needs to be up all the time. Your business requirements are documented very explicitly about how much bandwidth you need, how much, what kind of quality of service, what the security requirements are. You might have to write a project charter, like you do in other classes. That's why we have you do it so frequently. You might have to do a request for proposal to your hardware vendors when you're getting new firewall technology. You might have to write up an SLA as a network engineer. You might have to write up new procedures for your junior network engineers. You certainly have to know how to create a network diagram, and you might have to write up some security policies. There's an awful lot of business writing that goes into being a good network administrator. A good one. A bad one doesn't document anything. They just say, screw it, it's job security, and if they fire me, nobody else will know how to do it. Well, that's a really selfish way to be, and I would call that downright evil. Good system administrators document everything, and they're very team-oriented and want to help other people learn how to support the network, and that's what I would encourage you to do. So the last idea, and I'm sorry that I'm having to do a video of this, because typically this is an in-class activity, where if you go to this PDF, and you have to go to this PDF and read it, but normally I make this a dramatic reading, and so I pick two people in class to do a dramatic reading, which is usually hilarious. But read through this document to make sure you understand the difference between a managed box and an unmanaged box. An unmanaged box, an unmanaged switch, for example, you're going to spend less money. A managed box, you're going to spend more money. You have to know how to justify getting a managed box, and part of it has to do with my design principle number 3. But it also goes back to the fundamental aspect of business requirements, that you want to maximize uptime on your network. Well, one of the ways you do that is by spending a little extra money on managed devices. So please read this the Cisco document to get an example of that. And I will see you in class to talk about the next one. Thanks.